Howdy folks. So just a quick little video. A while back, this would be almost a year ago actually, I did a teardown, not really a teardown, I just did a reverse engineering of a JPT3815W wireless security camera by Tenvis, and it turned out to be a piece of shit. It bricked during a firmware update, and so I did a little bit of reverse engineering on the main processor board, but I never ended up taking apart the imaging head because I never really saw a big need to do it. So I ended up doing that today. Just, I was going to throw it out, so I thought I might as well see what was in it, and I found a couple things interesting. So this is the base, so obviously there's just a stepper motor in here which turns this, and there's this dual position limit switch that actually goes in both directions. There's 3 wires that come out of it. I would have thought this was only a single direction switch, so that's how they're detecting the rotation. And the head actually skates on a real greased roller skate bearing. It's a 6903Z, so I'm actually kind of surprised. I thought this would have just been, given the price, it would have just been cheap plastic on plastic, but no, it's actually got a real bearing in it. So that was kind of interesting to see. And then there was the imaging head. So obviously there's just a speaker which is glued in on one side, and there's another stepper, exactly the same stepper, except this one has a different end on it, and there's another switch, there's a limit switch inside there. I'm not sure if you can see that. It's the exact same blue switch as this one, and there's a little notch cut out in this piece of plastic which detects the tilting limits. And then there was the imaging, and I had deduced earlier that the main connector that came out of the imaging head was actually USB. So it was just a standard USB 2.0 webcam, and that was what I expected to see in here, was just a standard USB webcam off the shelf, and then they would just have some LEDs, maybe even some sort of ghetto wiring in here. I really wasn't expecting to see anything, but I noticed when I opened it that it was all one board, and this is actually a custom camera and LED driver board specifically built for this security camera. The chip there's actually 2 chips on here, and if you pull this out, which has 4 screws that hold it into the case, and there are 2 screws which actually hold the lens assembly on. If you pull this out, it's just a single board, and you'll notice right in the center it actually has a bare CCD or CMOS sensor. I can't entirely tell which one it is, but a bare die directly on the board there. So this is obviously some interest. It's a custom module, and of course you've got the photo cell here, all the infrared emitters, and just a standard green LED. So on this side we've got some transistors here, most likely for switching these. And then there's a crystal here which is standing up on its end, and it appears that is a 12 megahertz, I believe. It's very hard to see. And then there's 2 chips. So this right here is a PixArt ARK3399B, and this is just basically a raw sensor to USB 2.0 controller chip, and this is its companion E2 prom, which sets the vid, PID, product name, all that sort of stuff is all programmable through this. So yeah, I mean, this product is relatively hackable. I mean, you have a USB interface for the camera, and the LED and the like this LED. And this chip also has sound capabilities, although I don't think they're actually they're necessarily using them, because the sound from the speaker just goes straight out through this lead. So I don't think they're using the audio capabilities of this chip. But nonetheless, this camera, I mean, it's quite hackable. You could easily determine the pinout of these cables, and you could have your own movable head that has 2 degrees of motion, tilting and rotation, of course, you know, I mean, even if you didn't use the camera and you just use the LEDs and you put your own camera in here, I mean, it could be kind of useful for some sort of control project, and that's what I might do. I've got an FPGA dev board in, and I'd like to see what I can do with this. I kind of want to test my skills by trying to basically remove this chip and just get the sensor data directly off of the die and process it on my own FPGA with my own code and hardware. That's one of my next sort of board Saturday projects, but I'll let you know what becomes of that if I end up actually doing it. At this point, I'm still trying to make time for things like that, but yeah. Anyway, I just thought it was interesting. I mean, I thought this was a module, but no, it turns out it's custom. So anyway, that was a strange little look inside this. Thanks for watching.